Hi guys, welcome to the Homework 7 backside video. I literally just turned off the video for the first one, so it's going to be a quick turnaround for me, so hopefully that makes sense. We'll follow along. This homework is on frequency tables, which you guys absolutely annihilated last class. You did great, so congrats on that. So hopefully this homework felt pretty easy and exactly like we did last class. So looking at the first one, this graph represents the lengths of trout that a fisherman caught over 1 month. So on this x-axis, we have the length of the trout, and up here we have the frequency of fish that were caught within that size. So the reason I just kind of paused right there is I got a little bit confused, but over here we can see that they started the table for us. So the reason that it says between 20 and 30 and why the histogram isn't centered over the number is because we were looking between 20 and 30. So as we can see here, like in the chart, there were no fish caught that were between 20 and 30 centimeters, so that's why we have a 0 here. So looking between 30 and 40, which is this one I'm starting with now, I'm looking between 30 and 40. So I'm going to count. There's 1, 2, 3, 4 fish that are between 30 and 40 centimeters. Looking now, I'm going to go between 40 and 50 right here. You can kind of tell the difference with that color. It wasn't the best color choice, I'm sorry. But let's count. We have 1, 2 fish that are between 40 and 50 centimeters. We can also tell this one's about half as tall as that one, right? Which is another good way to check. Next one, we have between 50 and 60 centimeters. So let's count this one. We have 1, 2, 3, 4, 5. We can see that dotted line right there. 6, 7 fish that were between 50 and 60 centimeters. And last one, between 60 and 70. We have, this one was 7. We have one more fish, right? So I'm going to do 7 plus 1 gives me 8 fish right there. And going back here, so between 70 and 80, we can see that there's 1, which they give us in the table. So we just finished part A, which is great. Full disclosure too, so actually what we're doing next class is charts just like this and setting up our frequency tables using continuous data like that. So if you guys understand this, you basically just unlock the next lesson, which is pretty cool. So part B, throwing it back to the front side a little bit, state whether length of trout is a continuous or discrete variable. So here, that's kind of what we were just talking about, right? So remembering back to the front side, I said that when it says 20 is less than, the length is less than or equal to, and that pattern repeats, we know that that's a good signifier that this is a continuous variable. Otherwise, we know that length is a continuous variable, right? So it can be this long, it can be this long, it can keep going and going. It's very rare, or it will be very unusual to see a fish that is the exact same length down to the centimeter, down to the millimeter. So we know that this is going to be a continuous variable. Another good way to check is kind of what I talked about at the beginning. We can see that this histogram is between 30 and 40, which means that it's not exactly 30, exactly 40, and there's not exactly countable like that. So we know that we're going to have to measure it, and once again, you'll very rarely find 2 fish that are the exact same length. So we would consider that to be continuous. Moving on to the next part, so we have moved on from fish, which I think is probably exciting. This one is talking about grades obtained by a group of IB students. I know it's 1 through 7. We haven't really talked about this yet, but your IB external and internal assessment, I think, maybe not internal, but definitely external assessment at the end of your second year of IB is going to be graded on a scale of 1 to 7. So 7 is the best, 1 is the lowest score, but that's why they're using a scale of 1 through 7, just so you guys know. But they have listed out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 2, so 20 scores. And we are going to make a frequency table. At the bottom, I'm going to write total, just because we are good math scholars, and we are always going to write the total at the bottom of our frequency table. I am actually going to make tally marks by each of these, because that's how I keep track, and I really do lose track. But if you don't need to do that, that's totally fine. So I'm going to start here. We have 1 for 6, 1 for 2, 1 for 5, 1 for 3, 2 more for 5, 1 for 6, 1 for 2, 6, 1, 7, 6, 2, 4. Ooh, first 4, that's exciting. 2, 4, 3, 4, 5, and 6. So looking through that, let's count up and see how many we have. So we have 1 for 1, 1, 2, 3, 4 for 2, 2 for 3, 3 for 4, 1, 2, 3, 4 for 5, which is good because this one was given, so we know that we're on the right track. 5 for 6, and 1 for 7. So what number am I hoping to see in that total? 20, right? Because we had 20 scores up here. So let's add these up and hopefully I get 20. So we have 1 plus 4 is 5, 5 plus 2 is 7, 7 plus 3 is 10, 10 plus 4 is 14, 14 plus 5 is 19, 19 plus 1 is 20. Woohoo! So we know that we did it right. That's very exciting. Lastly, we have to answer this question. I'm not going to write anything down for this because I think this should be in your guys' words, but if you're confused, you can listen to me talk about it a little bit. So in your own words, what does the data on the left represent? What is a frequency table? How is representing data in this way beneficial, and how can it be biased? So this data over here, once again, we're talking about the number of students who received certain scores on their IB exam. So over here, we're keeping track of the number of students who received each score. So what is a frequency table? A frequency table allows us to organize our data such that we can see how many examples we have of a given category. So on the left, it's for grades. At the top, it was length of trout. So frequency tables lets us see how many of a certain category there are in each one. And so how is representing data in this way beneficial? So we kind of talked about this already. So it's beneficial, right, because we know it's hard when you just have random scores written out like that, right? Like I wouldn't have known how many of each one there were. So organizing data in a frequency table helps us to better see the data just in general. So we can see which one was most common. We can see which one were least common. You can get a lot more information from your data when it's organized. So representing data in this way is beneficial because it helps us to organize data to see patterns. And so how can it be biased? That's a great question. So data can be biased. We talked about this in class a little bit. So data can be biased when we have a certain goal in mind, right? So if we know that we want to say that Cristiano Ronaldo is better than Messi, sometimes people might only write statistics that show how good or how much, might only show data where Ronaldo is better than Messi, right? But as we all saw, there were some categories where Ronaldo had better stats and some categories where Messi had better stats, right? So we need to be careful with our data because we need to be unbiased in how we present it, but people can be biased when they want to argue a certain point and they use it to only support that point and they don't address how it can be different. So I know that was kind of a long explanation. I really do want you guys to take the time to write your own explanation, but hopefully that kind of helped you get started if you weren't sure exactly what to say. So this is the end of the homework video. Once again, if you have any questions, please talk to me or Miss Avra, and see you guys tomorrow.